Good afternoon, good evening, good morning, everybody. This is Peter Joseph, and welcome to Revolution Now, episode 59. It has been a long minute once again. I apologize for that. But things have been very productive behind the scenes over the last 2 months, I suppose. And I really do mean it when I say I want to get these podcasts happening on a more periodic and frequent basis. And it will happen. It will happen. I want it to happen because I don't like this big gap, lack of continuity. But I can only do so much at this particular point in time. So, integral development infrastructure has had some really good strides since the last podcast. The website is now up. It needs a little cleanup as usual, but I think it works fine as it is. It includes some good intro info with some walkthrough simulations of the 5 systems as they're currently presented with their modules. There's an FAQ, which will be greatly expanded over time. I think that's going to be an important component. As far as the style of the website, I went with a kind of minimal retro style to support the programming theme. But if you don't like that hacker aesthetic, then there's a button in the top right-hand corner that switches to a clean, more standard look. I still have some CSS work to do on all of this, but it's readable enough. And if anyone finds an overt problem with formatting on mobile or typo or whatever, please just use the email contact form on the site. Now, beyond that, people can also download the white paper and the new developer's guide, which I don't think I announced last time this podcast occurred. And of course, all of that and more is integrated into GitHub and Discord, both of which have been set up with an initial structure that includes all such documents in preparation for more. The critical review of all this is what phase 1, so to speak, is going to be. As of right now, if you're GitHub savvy, you can fork those repositories and take a look at them on your own time. But the infrastructure for Discord and GitHub is currently view only. It's just there to have a placeholder while applications come in to gain access, which one can find at the community page on the website. It's a very simple, straightforward series of questions just to see where people are as a kind of filter, how serious they are to even fill this thing out, etc. Strengths and weaknesses can be assessed along with some critical review that I've already been very appreciative of, is as per the questions where people can describe their current perception of the project in its crude form. And again, that's been very informative. I do want to point out that the development ecosystem we're trying to set forward is not for just passive interest. What we're trying to do right now is build a working group of people that are inspired by the project, that have a critical analysis of it, that have an actual positive intent to want to see something like this come to life. That's really the only fundamental requirement. No one has to be a hardcore developer or have some fancy degree, even though expertise is going to be important on a certain level at certain points. All kinds of thinking matters here in the context of essentially creative problem solving. One never knows where that one spark will come from when we're trying to build something of this nature or any kind of project. In fact, very often the most educated or institutionally regarded people are actually locked into a frame of reference that can be ineffective. It's that conditioning of academia, as we've talked about in other podcasts. And then someone comes along from a very different, unorthodox background, and they're the ones that actually make the breakthrough because they can see it from a different angle. So that said, we need people that are positive, thoughtful, patient, and realistic to form a foundational group, and it's going to be challenging to attempt this in an all-volunteer aggregated way. As talked about in the white paper, it might not work, which means another route will have to be taken, but we'll consider that when we get there. Now, as far as the broad strokes of this phase 1 as a general marker noted on the website and in the developer's guide, this is about broad initial planning, figuring out what we're going to do and how to do it. Questions such as, are the modules and principles behind them truly workable? Is there a certain function that is completely and utterly technically unfeasible? So the white paper is a starting point and developer's guide giving a starting strategy, but it all needs to be thoroughly evaluated before anything is built, needless to say. And once we figure all that out, we move on to phase 2, which is the build. But I will emphasize that phase 1 is absolutely critical. There's so much to go through, and we'll be continuing to talk about all of that through these podcasts my Substack articles, and of course, when meetings start to commence and people begin engaging in Discord and GitHub. Now, what is actually approached in phase 2, which again will be figured out, but here's my suggestion. As per the developer's guide, there's a minimum viable system architecture that's been put forward. I think you start small and then you increase complexity. Vertical slicing, I believe they call it. How you come to terms with what to keep and what to pause is, of course, up for debate. I would also add that the CDS, which we're going to talk about a great deal today, could be an important initial focus in all of this because it can be used in the actual build of Integral in a self-similar reality. But until that time, we'll structure out something in Discord in terms of coming to a general consensus of things, moving that into GitHub, and then pull requests, blocking objections, and other elements of that general method will be put forward for those that are familiar. Then we have phase 3. Phase 3 is testing and simulation. Whatever's built in phase 2, we have to test it. And fortunately, there are a lot of advanced ways to do this now. Testing in segments of the system and testing the system as a whole, agent-based modeling and things like that before we move into phase 4, which would be real-world application. I also suggest that one bridge to phase 3 to phase 4, while phase 3 will focus more on automated testing of segments. Phase 4 can be led into by a virtual node established by the online community. So if we have 50 developers that are doing this, we have all of us come together to be a virtual node, and we run a full node simulation, come up with different scenarios, different problems. Say we're going to build a vertical farm, we run through all 5 systems, we introduce as many problems as we can think of, et cetera, et cetera, et cetera, including, in fact, legal and regulatory issues, which I'm going to talk about a little bit here in a second. So I think it's fairly straightforward how that kind of exercise could be constructed. And then you run multiple scenarios. You come up with a mesh network, cell phone construction. You come up with a Uber-style shared transportation system. You come up with a project development simulated for a micro solar panel array. Remember, the initial steps of this kind of mutual aid-based approach, which is very deliberate, is to get the foundation of how we live down in a minimal form. We're not going to run out there with Integral and try to build something luxury. That's against the point of the entire thing. Because at the core of Integral is this minimalism I talked about before, at least as an initial state. We want people to get off the grid of the current system. They have to. So I don't want to go on that tangent. But in the simulations we put forward, those should be the focus points. The most core things where someone can get up one day, go through their entire day utilizing the system, and they don't have to spend $1. They're not engaging the market. They are off the grid. So anyway, you set up those scenarios, you run the virtual node simulations, various constraints and problems are introduced, et cetera, et cetera, et cetera. And then we have phase 4, with the actual physical implementation of a minimum software suite, most likely. The protonodes are focusing on these core survival elements I just mentioned. I say this because this could happen fairly quickly in this measured, scaled, simplicity to complexity method if it's designed strategically. There's a lot of inherent complexity to all this stuff. The assumption of Integral, which separates it in part, is the fact that it recognized the need to move away from these small social reciprocity systems that have existed for literally hundreds of years in slight antagonism to general competitive market trade behavior and expand them so they can actually work on a truly advanced modern scale. And of course, the protonodes themselves could probably engage in their own simulations to start. That could be part of it, where the protonodes get their actual physical people together. They look at their resources, the landscape of their actual ecosystem, and they begin to run simulations that are kind of built into the system, in fact. And I'll say one more thing in terms of phases, even though this is way down the line, but it's worth noting, since we're doing this holistic context here, that broader network development will eventually emerge, where internodal coordination, application of coordination envelopes, as they're described in the white paper, methods for internodal problem solving, resource sharing, problem solution coordination, other forms of distributed coordination across the network That has to be introduced, tested, and so forth as well. It can't be just ignored at this time. So ultimately, a proto-node is just not connected to anything yet. They have to be connected to be a true node, just by definition. And again, that's way down the line, but it's something that we have to think about in this sort of holistic approach. In fact, I want to say something about the legality and regulatory environment quickly, because I've gotten a lot of emails on this. This must be taken seriously and into account as a general constraint for any potential node. Integral nodes, if they emerge, are going to be alien entities within a vicious legacy economy. And that has to be just as important of a consideration as how the five systems flow in general. Tax situations, legal status, interface mechanism, attributes, meaning things that are engaged in the legacy market economy for resource acquisition, as talked about before. Questions such as, should a node be a nonprofit? This is country specific as well. And the thing is, it might, in fact, the more we learn about this kind of general restriction, even though it's fluid to a degree, is it might change the structure of the way Integral is actually built. We might have to alter the ITC dynamics, in fact, to conform, or at least try to anticipate a less tense environment if something strange happens, like some kind of structure like this is actually in violation of tax law. It's unfortunate to think that way, because you're basically having to reduce the system's design to fit an inefficient environment, but that's life, which is partly why I've commented in the past that the United States might not be the ideal setting for mature integral nodes to grow and advance, not only because of the potential tax issues, but also because of the cultural state of the US, which maybe I'm wrong, but seems to embrace a far more selfish and competitive character on average than we see in other countries. The rise of Donald Trump kind of speaks to that, I suspect. But even in the United States, with all of its inherent limitations, as it exists from a legal tax standpoint, Integral still fits quite well as it is in the profile of a mutual aid construct focused on social reciprocity. The core supporting precedent for this are the existing time banks that have been around for many, many decades. If you look at Time Banks USA or timebanks.org, they do not operate in a tax capacity or as a formal economic institution. They've gotten away with it. The founder of timebanks.org was Edgar Kahn, who was an attorney and legal scholar, a brilliant guy, and he spent a great deal of time researching this reality as he developed timebanks.org. And I actually have him, by the way, in an opening section in my new film. I found his work to be very influential because he pushed the limit and he understood why, even though it doesn't go quite far enough. He literally approached the US government and the IRS and was able to reach a conclusion with them that time bank exchanges are in fact not taxable because they're mutual aid, which is a category. They're not commercial exchange. Credits are non-transferable. There's no market valuation occurring, which you could argue that, but there isn't, not in the structure. And there's no profit intent and there's no conversion to cash, which is precisely the condition of Integral, even though it's a bit more granular in what Integral is trying to do. But all that said, there is good precedent in support of the foundation of Integral from a legal and tax basis. Now, that doesn't mean things can't change or accusations assumed if the network grows to a point of starting to affect the legacy market economy. This is to be expected in terms of pushback. Anyway, all of that said, something to keep in mind. These are important things to anticipate. But I'm optimistic that this isn't going to be a big issue anytime soon, especially with the scaled, incremental nature of the development. But again, we've got so much work to do before we can even get to that point. Okay, let's shift gears here now and talk about democratic decision-making in the truest sense of the idea. We talked a bit about this in the last podcast, but we're going to go into more granular detail in terms of actual approaches as we get into the CDS. The first thing I want to cover, which I find fascinating, is Stafford Beer's Syntegrity. It's a high bandwidth, small group decision-making method he developed in the late 1970s. In the integral white paper, this method is proposed as a kind of last-ditch effort to find consensus in an interpersonal way. Once consensus attempts in Module 6, which we're going to talk about in a moment, fails. Module 6 in the CDS pipeline is that module that attempts to reach final consensus on the given issue or set of scenarios. Module 6 is not just like some vote, it's an assessment of preferences and objections, again, as we'll talk about. And if that consensus fails, one option is to jump to Module 9, which is an auxiliary module that attempts to do more manual fleshing out of the problem, which includes utilizing syntegrity. So what is syntegrity? I'm not going to go into every little detail about it, but I do recommend a paper by Beer's former partner, in fact, Elena Leonard, called Team Syntegrity, a New Method for Group Work, which was written in 1996, even though there's been good documentation since then with people utilizing this method. In short, Beer did something quite interesting as an inspiration, which is take the geometric surface of the icosahedron, which is a 20-sided polyhedron. What I'm holding in my hand is an 18-sided polyhedron or octadecahedron, but you get the idea of the shape. What is it? It is a networked structure. It is not hierarchical. There's no top, there is no bottom. And Stafford Beer bases the communication structure of group interaction in syntegrity on this kind of networked element of the icosahedron with 20 surfaces. And uncoincidentally, this is also the structure Buckminster Fuller put forward in his famous geodesic dome and the Dymaxion world map, where he imposes the entire world on these surfaces. The icosahedron has 20 surfaces, but 30 edges, and Beer maps each edge to a participant. Hence, 30 is the traditional number involved. That's how many people go into it to make a decision, but it can be scaled, and this has happened with smaller and larger based on the multiplied geometry of the surface of this, which has its own constraints. And there has been consideration of expansion to more people because that's essentially the problem. If it's only 30 people or slight variance therein, it doesn't help for large-scale decision-making. But it has been pitched, and I believe Beer talked about this as well, even though I don't know of any evidence of it happening, that you could have, say, 300 people, and you divide it into 10 groups of 30, and basically you have the sessions unfold, and then agents from each of the 30 move up, and then the session repeats, again, in a recursive way. But as far as the basic process with the 30 people, which are the edges represented in the polyhedron, the vertices represent topics of interest, meaning that there's an angle taken to the value of what's being proposed, and they're arguing in this symmetry. And everyone is broken into teams in this way. Again, I'm not going to go through the complete nuance of it, but let's understand the cybernetic principle here, which is variety management once again, accounting for the diverse opinions of people rather than merely collapsing it down into some raw vote like we do in traditional democracy. Basically, what Beer put forward was a kind of manual human algorithm, which has proven quite successful in almost every single case I've read about this, which is why I included it. If you have a small group of people and they just are having a really hard time, there's a value judgment problem, things that really need to be fleshed out on a personal level, as tedious as it is, this is one kind of fallback. Now, this begs the modern question, though. Can it actually be expanded through programming? Can you use modern automation tools and calculation and maybe even AI to streamline what is ultimately a very high bandwidth personal face-to-face and slow process? And in the 1990s, there was some kind of partial software development and application, but I don't think it was embracing the entire system, if I remember correctly. And I kind of looked around for quite a while to see if I could find anyone that had really tried to digitize this process, but I haven't seen it yet. If anyone finds that, please send it to me. So back to Module 9 of the CDS, which again we're going to talk about. I threw this in there, so to speak, because I think it harnesses the true sense of community through a very intelligent strategy as put forward by Beer. Will it be useful if it can't be scaled? I don't know, but these are things to explore, which is why it's there. But what separates the CDS of Integral, what it's attempting to do is embrace the full journey as we can conceive of it, from raw input, critical data analysis and constraints surrounding an issue, to structured understanding, to decision, to execution, and then back to revision through feedback as a review process. The CDS starts from the premise that decision-making is a sequence of transformations. Something is noticed, then defined, then understood, evaluated and discussed, then decided and acted upon, and then reviewed once again. That's the cycle. And if any of those steps are weak or fragmented, the outcome degrades. And remember, the integral CDS isn't just general policy decision creating or something. This is about tangible stuff in the end as a foundationally economic system, even though the CDS can apply in theory to any kind of decision making. So that said, what I'm going to do now is go through all this module by module, explaining the principles and processes behind it, and also pointing out the caveats and gaps in the existing white paper, to which there are many. So first, let's do an overview of the entire thing module by module, and then we'll go through it again with further details. Module 1 is intake. A problem of concern or a proposal is input into the system, which validates the source, timestamps it, and removes any duplicates, and packages it for Module 2. The inputs coming into Module 1 do not just come from people as well. They also come, when necessary, from the other 4 systems of integral, when those systems trigger alerts to a given problem. Module 2 then takes this flow of information and structures it using argument mapping and semantic clustering, outputting a data object for then Module 3 to process. Module 3 is a data retrieval process that takes in the structured data from Module 2 and retrieves relevant information from the other 4 systems. For example, if the issue is a broken machine, Module 3 searches out relevant data surrounding that machine from its acquisition to its history, to its repairs, to its general context of use, and so forth. Extracted, again, generally from the other 4 systems. Is it completely exhaustive? No, of course not. It depends on what the circumstance is. If the issue clearly requires deeper investigation in general away from the other 4 systems, then that can be queued in, so to speak. And when Module 5 rolls around, people will understand that there's other information they may need to extract from, again, other external sources. So Module 3 is about finding the context of the problem or the proposal. Module 4. Now, Module 4 extends this kind of retrieval process into constraints, norms and constraint checking. What is a constraint? It is something that has to be abided by as a rule. This pertains primarily to proposals rather than assessing problems, even though problem resolution, as said before, does inevitably involve proposals. It's important to point out that constraints are perhaps the most critical aspect of the guiding methodology of integral in totality. It's what's missing in the world today in any intelligent strategic understanding. Constraints are not inhibitions. Rather, they constitute the path of proper responsible action to do things right. I'm not going to talk about the OAD, the open access design system today, but it's worth pointing out that it is also deeply rooted in this kind of constraint mapped logic, rooted fundamentally in environmental and sustainability concerns, the OAD. That said, the CDS module 4 constraints are retrieved from the other 4 systems, rooted in relevant metrics, right? While also referencing any constitutional constraints or constitutional rules that the node sets up for themselves. So like Module 3, which is taking in relevant context information, Module 4 is pulling in constraint data, and all this is going to be very, very helpful when the humans come together in Module 5 for debate and conversation, being as informed as they can be. However, there is a difference. Unlike Module 3, which is context data retrieval, Module 4 actually does make judgments and comparisons against whatever information is in the proposals. Moving on, it's important to point out, and this is a little vague in the white paper, there is a bridge step between Module 3 and Module 4, which is the auto-generation of proposals. In other words, a set of proposals that are automatically generated and added to the pipeline to be processed like all other proposals at that stage by Module 4 through constraints. Module 1 doesn't just take in general proposals, it takes in problems to be resolved. And the Module 3 bridge to Module 4 is looking at those problems, looking at the environment and saying, okay, we're going to infer a few things here to get the ball rolling into Module 4 for constraint analysis. So then we have Module 5. This is the grand participatory deliberation workspace. Everything up until this point has been automated since submission, and the community has been notified that there are proposals and problems that need resolution in their node. And in Module 5, there are a range of tools, as discussed prior, such as objection mapping, preference gradient expression, and others that are incorporated to help try and figure out what to do and find consensus. The team now has collected data from Module 3 regarding the issue in question, the context, along with relevant constraints as they apply to proposals that need to be abided by. In Module 5, participants can look through all this, they can propose new solutions, they refine auto-generated ones or initial ones, etc. How the actual human engagement process works in Module 5 is not specified in the paper, but a structured workflow is going to be extremely important, which needs to be figured out. That said, what comes out of Module 5 generally are two things: a final objection map and a preference gradient for each given proposal for consideration, which are aggregated from the final conclusions of all the participants upon the decision at some point to move to Module 6 for this processing of scenarios, as it would be called. Now, regarding Module 6, this is referred to as the weighted consensus module, and it calculates the objection map and the preference gradients created in Module 5. And it arrives at one of three conclusions. It can approve a scenario or multiple scenarios, which we'll touch upon a little bit later. It can push back scenarios to Module 5 for revision, or it can escalate things to Module 9, which once again is the more hands-on approach that includes integrity as a last resort. And for the sake of this very brief overview, we're going to assume it has been approved, which moves things into Module 7, which records and versions the decision. It documents in the metadata everything that happened to get there for the sake of record and transparency, which then leads to Module 8, which is the dispatch of the decision to the relevant areas of the system, setting the decision in motion, in other words. And generally speaking, Module 8 is kind of the end of the core process, with, again, Module 9 being the backup for consensus, while Module 10 is the decision review procedure that may happen weeks or months down the line. It depends on how things are actually working out. So that's the overview. And it begs a question about monitoring the efficacy of these decisions within the system, right? And that should be understood as being distributed. In other words, the way the system watches itself is primarily through the feedback review system, the fifth system, the FRS, which is more of a total awareness system for the health of the node. It doesn't take in every single tiny metric, even though one could argue it could in a small node, but its purpose is to have a holistic sense. But the other four systems maintain their own internal monitoring, with the exception of the CDS. The CDS doesn't actually monitor, it responds to the other three systems, I should say. So the OAD, the COS, and the ITC system are all utilizing their own internal monitoring structure as dictated in the white paper, with some of that data aggregated and moved towards the FRS for a more holistic picture. So in other words, if something comes up that needs to go to Module 1 of the CDS as an alert from another system, this is where it's coming from, either from the FRS as holistic monitoring or from the other three systems that have their own monitoring structure within them. So that said, that's the pipeline in a nutshell. Now we go through it all again in finer detail, as there's a lot of nuance and clarifications that need to be made. Back to Module 1, issue capture and signal intake. As stated, there are two input sources. First is person introduced. Second is system generated alerts, as just touched upon. Now that's said in regard to human proposals or observations of problems or issues. We have the issue of scope. what kinds of problems or proposals should count as a node level concern as we are describing? Should everyone that sees anything wrong or has any general project whim just instantly go to the node CDS interface and express themselves, regardless of the scale of the application? In a very small node or proto node, that distinction may indeed barely matter because everything exists on the same operational level with just a few co-ops and whatnot. But in a more developed node with hundreds or maybe thousands of people working across many different cooperatives, it would be too nonsensical for every small issue to be evaluated on the total node level CDS. And this points to something not quite clarified in the current documentation, even though it is implied. The co-ops within an integral node are recursively decentralized, just like the node itself is in the network, regional network as a whole. In other words, just as a node would function as a self-governing unit within the broader integral network, assuming multiple nodes, each cooperative functions as a smaller decision unit within the node itself. In other words, co-ops are sub-nodes within the regional node. So in a well-established dynamic community, it becomes impractical for an entire node population to address every minor issue that arises. If there's a simple lighting malfunction in some co-op building, there's no reason to elevate that to the total node community because it can be resolved on that level. If 20 people are in a vertical farm system and something's going wrong, the team assigned to that system will take on the burden of that initially and decide if it needs to be escalated to a node level CDS. This is all common sense, but it's worth pointing out. It is only when a problem that needs resolution or proposal expands the scope of that co-op that it becomes a node level concern. And that usually means consequences overflowing between the local co-op, beginning to affect other cooperatives or something in the environment, et cetera, which then begs yet another question. If there's 20 people in a co-op dealing with a problem or a proposal, how do they actually reach consensus? Well, as per the consistent idea of recursive self-similarity in a cybernetic sense, the answer is that they have their own scaled down CDS system as well. This could be an adaptation of the existing node CDS. It could be a submodule of it. There are lots of ways to approach it, but it's the idea that matters. Again, that core cybernetic principle of recursion that creates multi-scale cohesion while preserving decentralization and autonomy, which is critical and rational. And what happens if that decision has adverse effects they didn't see? Well, then that becomes a consequence of that, and then it gets elevated to a CDS node concern. In the exact same way that the nodes in the network, if there is a overlapping regional node issue or proposal, that gets escalated through coordination envelopes as per the white paper. This kind of scaling to resolve a problem and a reduction of it. This is a variation of the idea, which enables a form of large-scale multi-node collaboration without overt hierarchy being established at the same time, again, as per the white paper. Okay, back on point. So, Module 1 on the common community level, again, takes in human signals from reacting to a problem to proposing new projects, while also potentially getting problem alerts from the other four systems, primarily, most likely, the FRS, since again, its job is to monitor overall node health. Such alerts can have a vast range of reasons, and it's best to think of it in terms of logistical alerts that are common today with, say, factory distribution. If Amazon distribution center runs low on some kind of inventory, they have an automated system naturally to alert, and correction is set in motion. So this is basic stuff, but it is an important nuance to talk about structure, as the system is only as intelligent as the way it can communicate when it comes especially to these automated data flows. And same for the input structure for humans submitting in Module 1. As noted, and as we'll get to more so, Module 2 is what has to deal with sorting what has been submitted in Module 1, and it can come from multiple overlapping simultaneous sources. Again, the assumption of complexity is consistent here. So the stronger and more organized the inputs, naturally, the better. Again, this is common sense, but just imagine a kind of structured submission form that very thoughtfully thinks about the variables in question in terms of the overall submission not specific to the submission, but just what needs to be known as a general template. Now, with respect to Module 1 and the supportive data I've mentioned, the submission of schematics or photographs or reports regarding problems, these carry over to Module 3. They're not processed by Module 2. It's a pass-through. Now, it's worth considering that large language models these days can dramatically assist Module 3 as part of its structure. So you have evidence and documentation, various formats and whatnot. This is much easier to digest these days than it used to be. So it's something to keep in mind and may very well assist this structured complexity I'm referring to in the context of submitted evidence and data in Module 1 to be interpreted and collected once again in context for Module 3. Just want to throw that out there. That said, Module 1, it's all about validating authenticity, removing duplicates, and ensuring the intake is sound, adding a timestamp to the record. So let's imagine a scenario where some problem has made itself present, and many people have experienced it, and they've all flocked to the CDS within an hour or two to report it multiple times. Module 1 is designed to deal with that multiplicity of duplication, multiple submissions of the same thing. So when a submission arrives, Module 1 converts its text into an embedding, technically, a numerical representation of the submission's meaning, and this allows two or more entries that say the same thing in a different language, such as phrasing, "The bridge floods during storms," or "Heavy rain is covering the bridge walkway." These could be recognized as equivalent, while entries that only sound similar on the surface but mean different things can stay distinct. So Module 1 compares that embedding against every existing submission on the same issue using cosine similarity. Again, this is in the white paper, which produces a score between 0 and 1, where 1 means essentially identical in meaning and 0 means completely unrelated. If the highest score exceeds a present threshold, which I won't go into, the new submission is flagged as a duplicate and absorbed. And note, duplicates are not just thrown away. The original submission is indeed kept as a canonical entry, if you will, and the duplicate is recorded as a linked reference pointing back to it with the duplicate's author, timestamp, and other metadata. So that is essentially the entire job of Module 1. Clean, attributable, non-duplicate input ready to be handed to Module 2 for thematic organization, which brings us to Module 2. So Module 2 takes this authenticated, time-stamped, and deduplicated input from Module 1 and begins organizing it for easier comprehension. Now, in an active node, multiple people may raise individual concerns, observations, or even proposals that actually touch upon the same underlying problem from multiple angles. I don't mean a singular problem, but a set of related problems. And Module 2 is here to figure that kind of thing out automatically. Naturally, if you imagine someone's reporting multiple problems in a given co-op, that context will be stated quite explicitly, and so there would be clustered in that way, be condensed in that way, obvious enough, easy to figure out, easy for the system to see that. But if there's a relationship there that isn't seen or explicitly denoted by the people that are submitting, Module 2 ideally gets this done. So where Module 1 handles duplicate submissions, catching near identical entries through similarity matching, Module 2 handles related submissions, grouping them into coherent themes so the deliberation space becomes navigable rather than just this flat list of individual entries where people have to figure out the associations themselves. Now, more technically, as stated, Module 2 uses semantic clustering and a framing logic to group these related submissions, and it happens in 4 types: proposals, objections, comments, and system signals. Once again, just to be thorough here, evidence submissions from Module 1 are not counted here. They are indexed and later addressed in Module 3. So overall, Module 2 identifies themes, reveals overlaps, and even conflicts, and delineates the underlying structure of a given issue, a proposal, or a problem. Again, it all assumes a stream of messy observations, concerns, and so forth. And in an active node, there could be dozens of inputs into Module 1 per day coming from many different directions with many different intentions. Now in the code, Module 2's output is a structured issue view pipeline object, one per issue, which passes to Module 3 for contextual assessment. So let's move on to Module 3, Knowledge Integration and Context Engine. Module 3's primary organizational input is this structured issue view that Module 2 produces, which contains organized information about the issue in 4 main parts. First, there is the issue ID, which is simply the identifier. Second, there are the clusters, the core organizational field. This shows the internal structure of the issue as output by Module 2, and hence in simple terms it says here are the major threads or groupings within the issue, assuming the issue is complex enough to contain them. Clusters are not summaries or paraphrases. They're again groupings of the original submissions organized by thematic similarity. And in the formal sketch of the white paper, each submission cluster inside the clusters collection contains its own fields as well, including a list of submission IDs, which means the cluster can be traced back to the original submission that entered through Module 1 if needed, as touched upon before. Third, there are the themes themselves, which is this high-level list of inferred topic labels that Module 2 has identified from the clustering process. And fourth, there is the metadata, which describes what Module 2 did to produce the clustered and themed issue structure for transparency. Now, with this structured input in hand, Module 3 uses it as a routing guide to gather and organize the contextual data surrounding the problem or proposal being put forward. Its job is to build the factual landscape around the issue. So it pulls in relevant information from the other integral systems, the FRS, the COS, the ITC, the OAD. In effect, Module 3 says, before we debate a proposal or debate how to respond to a problem, let's make sure we actually understand the context of the situation in enough detail to clearly think about it. That is the underlying reasoning. And again, I suspect large language models could really help bridge this, considering where we are with that kind of technology, which can be localized, scanning complex databases and returning context-relevant information in a format that Module 3 consolidates. And what does it consolidate it all into? It's a context model data object, which we're going to talk more about. Before we move on to Module 4, there is a bridge step, as commented on earlier, between Module 3 and 4 that generates candidate scenarios. The bridge step digests the organized information coming from Module 1 through 3 and produces a set of candidate scenarios for Module 4 to evaluate. These proposals are in addition to what comes from the initial submission in Module 1, as talked about before as well. So it's adding to the existing proposals. If someone actually had a problem they recognized and filled in the field for their own idea for a solution, which should be part of the structured form intake, that would also be a candidate as well. Now, as per the white paper, the bridge step, as noted, is in the orchestrator in the pseudocode, but isn't discussed in the prose. This was an oversight of the paper. Okay, that understood. Module 3 outputs this context model, a structured object containing information about the broader reality surrounding the issue. Historical records, system dependencies, ecological indicators, supporting evidence, resource and labor profiles, fairness signals, what have you. The context model becomes available both in the bridge step, which uses it in the scenario construction, and in Module 4 itself, which uses it to check proposed scenarios against those same conditions. Module 4 is where the first true evaluation, so to speak, actually takes place in the CDS. Everything else has been kind of developmental, gathering, organizing, contextualizing, proposing. And Module 4 is where the system actively assesses whether a given scenario or proposal will hold up against ecological, material, labor, fairness, and constitutional limits once again. That said, Module 4 processes and outputs a constraint report object for each candidate scenario, recording whether the proposal passed the relevant checks, what violations were found, and by nature of that, how modifications would emerge for it to become viable. So if 3 proposals are under consideration, Module 4 produces 3 constraint reports, each individually qualified and described. Then we arrive at Module 5, the participatory deliberation workspace. Now, everything that has occurred so far, from initial input into Module 1 up through the output of the constraint report from Module 4, has been part of the system's preparatory pipeline, and Module 5 is where the human community enters the process in a direct and structured way. To summarize again for clarity, sorry to be so repetitious, but Module 1 captured the issue or proposal. Module 2 structured it into a coherent issue frame, whether the input began as a problem report, a proposal, or some combination of both. Module 3 assembled the relevant context around it. Then there's this bridge step between Module 3 and 4 that generates candidate scenarios, meaning possible response paths or solution options that could actually be evaluated. Module 4 then filters the scenarios, all of them, through the system's ecological, resource, labor, social, and constitutional constraints. So by the time the issue reaches Module 5, the community is no longer dealing with all sorts of loose impressions and random information. In other words, it's an extremely efficient secretary. Okay, now, Module 5 and Module 6. These go together. What comes out of Module 5 from human deliberation is what goes into Module 6 for consensus calculation. Module 5 can be thought of as a multi-user deliberation environment where participants can interpret the issue and proposals in question, examine the available scenarios, review the constraint reports, raise objections, compare alternatives, compare multiple scenarios, and contribute ideas, refinements, invent, etc. This is the reasoning space, a critical one. And there are tools here, as touched upon before, such as objection mapping, semantic discussion threads, scenario comparison, once again, the preference gradients, pros and cons visualization. These are all in the white paper, and potentially other aids. This is just the beginning, and I'm sure plenty of other tools will arise over time. In the white paper, the outcome of Module 5 into Module 6 has 3 core elements: the active scenarios or proposals under consideration, the objections attached to those scenarios, and explicit support signals, which range in a gradient from strong to block. These 3 elements allow Module 6 to literally calculate 2 things for each scenario: a consensus score and an objection index. It then uses those 2 results together to determine whether a scenario should be approved, revised, or in fact escalated to Module 9 for more human intervention, if you will. And I'm going to go through each of these elements in detail in a second. But first, since we've touched upon this prior, let's just kind of investigate a little bit about these analytical tools we talked about, as they are critical tools for analysis in Module 5. Let's start with objection mapping. What is objection mapping? Objection mapping is pretty common today, even though sparse, but in the deliberative decision-making world, it's relatively common in these systems, in these software systems, where instead of focusing on agreement from everyone, it focuses only on objections in this narrow way. So a proposal is put forward, and rather than jumping straight to voting or open debate, participants are simply asked after they review it what they object to, and asked for concrete reasons as to why they object, why would harm be caused, or what have you. Each objection is then recorded and mapped, usually in a visual cluster, often organized by theme. The goal is to find patterns that can inform everybody of the state of disagreement. So there's that. Next is semantic discussion thread analysis. Polis, once again, is a platform that attempts this. In fact, Polis could be, like others, incorporated into the preliminary development of CDS Module 5, as it does share similar things on the tools level. Similarly, there's the AI Objective Institute, which also developed this with a tool they call Talk to the City, which, again, is worth reviewing. The rabbit hole is deep when it comes to the emerging world of deliberative democracy on the level of analytical tools, especially, once again, with the rise of artificial intelligence and LLMs. But in short, semantic thread analysis attempts to find order semantically out of messy discussions like a series of engagements of a chat. Now, I still think initial structural inputs are far more important. I think people have to approach how they communicate with a very particular strategy in mind to begin with, not just flailing in conversation. But in the principle of this technology, you just take a transcript of something and it starts to analyze the state of agreement or disagreement, giving you a better sense of the total conversation. In the end, it's the combination of these tools that will have the greatest effect, and that's probably more of an art than a science. So next in the white paper, we have scenario comparison. This is underspecified, which is about finding ways to compare multiple proposals or scenarios against each other to come to an objective understanding of which is better. Now, as an aside, Module 6 actually does scenario comparison. That's part of its process, but there's a deeper level that needs to happen in Module 5 with respect to specific attributes and characteristics, which I won't go into. But let's move on. Preference gradients. Preference gradients are a core output of Module 5, as noted prior, which carries over as a core input to Module 6. There is nothing radical about this. This is also very common in deliberative democracy approaches out there. And the white paper suggests this 5-unit gradient I touched upon: strong support, support, neutral, concern, and block. Now, as far as the Module 5 spec with respect to these preference gradients, they exist at the scenario level, 1 gradient per participant per scenario. And Module 6 is designed to evaluate multiple scenarios, as I said, in parallel and then compare results. What the spec does not specify is whether gradients can also apply to attributes within a scenario. In principle, someone might want to apply this kind of gradient to internal discussion about not the scenario as a whole, but elements within the scenario. So a kind of sub-scenario gradient maybe could be introduced in this effectively recursive idea in Module 5 to better refine things. This is just a suggestion. It's not part of anything that's been proposed in the paper. That said, now there is one other clarification that's important in the pipeline that's described in the white paper specification for the CDS, and that has to do with the cyclical nature of things. The overall pipeline as presented is a linear flow, right, from Module 1 through Module 6, with Module 5 handling debate and refinement. And this would work for narrow cases, but it's not the only kind of refinement that happens in real-world deliberation. Participants may and will likely invent genuinely new proposals in Module 5, ideas that weren't in the original submission and aren't simply modifications of existing scenarios. In other words, a novel proposal introduced in Module 5 or a radical modification needs the same treatment any other scenario gets. It has to have its context profile built and its constraints assessed. And the fix is straightforward. Module 5 routes any new scenario back to Module 3 and 4 before admitting it to the active set in this circular way. Or this could be thought of more casually, in fact, where Module 3 and 4 can be seen as simply tools at the disposal of Module 5 participants, and they run them in the same kind of access they run their own analytical tools. So it doesn't have to be some kind of formal, abrupt thing, right? I make that as an intuitive comment. Okay, all of that said, let's return now to the more bare bones reality of Module 5, and excuse me for jumping around so much here. To clarify definitively, Module 5 is a sophisticated variation of a team of people sitting around a large table covered with piles of documentation pertaining to a proposal or problem that needs resolution. They are trying to build a contextual picture of the situation, assess relevant data and limitations, and work towards a solution. But instead of those loose piles and open-ended conversations, they're using structured analytical tools, objection mapping, scenario comparison, preference gradients, and they run refined scenarios back through earlier modules as needed, as just talked about. So that's the broad stroke. Now, the actual working method still needs to be considered, how we structure the conversation in Module 5. It can't just literally be sort of chaos. There has to be some kind of general process. Will it be perfect? Of course not. But that's something that needs to be considered as well that is not included or suggested in the white paper. Syntegrity, in fact, is that kind of methodology and form in terms of strategy, because that's exactly what syntegrity does if you look into it. But at some point in this deliberation, it finally reaches a condition where things are ready to move forward to Module 6. And 3 elements are brought to the surface and ordered, as they are to be the core ingredients for the calculation process that happens. These 3 are, first, the active scenarios that have been listed. These are the ones that have been decided upon for consideration. 2, the objections have been mapped and attached to scenarios they pertain to. And 3, participants have expressed their support gradients across the options on the table per scenario. When that three-part state is in place, Module 5 hands its structured output to Module 6. Module 6 then, in an automated process, takes over, running its consensus math on each scenario independently and producing for each a consensus score, an objection index, all of this resulting in three potential outcomes, which is approval, revise, or escalate, which escalate means to move to Module 9 because nothing is working. Now let's explore this in more detail in Module 6, again as per the white paper. Module 6 takes in those three core inputs from Module 5, along with a potential fourth variable related to participants themselves, which I'm going to get to in a moment. To repeat this for clarity, the gradient votes for each scenario, ranging from strong support to neutral to concerned to block. These carry numerical values between 1 and -1, as the system quantifies these relative preferences for the calculation. Second input, again, is the documented set of objections, and Module 6 assesses these to factor into the calculation. In this, each documented, refined objection carries two parameters, severity and scope, and each has a float range from 0 to 1. Severity measures how serious the objection is. If an objection relates to significant perceived harm, it might be 0.9. If it's minimally severe, it might be 0.2. As far as scope, it measures how broadly the negative outcome would apply. So an objection affecting a small group or a section of a co-op might have a scope of 0.1, while one affecting an entire network of co-ops might have a scope of 0.8. Now, where do these numbers come from, you might ask? As far as scope, I think this is relatively straightforward. Scope pertains to what's affected. So if it's a water supply and something's happening with it, we can assess who relies on the water supply, the geography of the water supply. So if the scope of an assumed objection affects 5% of the population, that's a relatively small scope. If it reaches 90%, it has a large or wide scope. However, severity is harder as it's far broader. Anyone being poisoned by a water supply is bad, but how bad or severe depends on specifics. If pollution has a high chance of causing cancer over time, severity might be 0.9. If it's mild and tolerable by normal human exposure standards, it might be 0.3. So we can understand such a range intuitively. Formalizing it is more difficult. Now, just so people know, this thinking isn't pulled out of thin air. There are examples of this kind of risk quantification already in practice. In fact, the mathematical approach is borrowed from the broader family of formal risk assessment methods, most famously failure mode and effects analysis, FMEA, which has been continuous in use since the 1960s in various industries like aerospace and healthcare. While the deliberative element of this, the philosophy, if you will, was inspired by sociocracy, which has been in continuous use since the 1970s and treats objections as information to be resolved rather than votes to be counted. Okay, input number 3 is this participant weight. The third input is participant weight, which has not been covered. This is controversial and in most cases would not be utilized at all. It refers to the idea that each person in a CDS node carries a degree of influence based on prior performance, credentials, or proven expertise. I was never going to put something like this into the system until I started thinking about extreme edge cases, situations where the issue under deliberation is so technically demanding that it requires specialized proven skill to evaluate responsibly and come up with a solution. The obvious danger of this kind of weighting is the rise of elitism, which cuts against the core principles Integral is designed explicitly to uphold. But we also have to be realistic. In the same way that I'm not going to stop someone on the street and ask them to prescribe medication for me or perform some kind of surgery, I will have to trust a doctor with a certain amount of background in that field. There are domains, in other words, where expertise genuinely matters. I should have specified the conditionality of participant weights more carefully in the white paper, but again, this is all about broad strokes, meant to get the ideas out there and get others thinking. So the edge case is simple. There might be something that happens in the CDS where complexity forces reliance on a minority opinion, who have, again, historically demonstrated the capacity to engage with them. On to input 4, threshold parameters. The fourth input is a pair of thresholds that help determine the final directive. Consensus threshold, which is the minimum consensus score required for approval. This spec generalizes this at 0.72. You could crudely interpret that as 72%, but again, it's not a percentage, even though it's pointing in the same direction. It's a point on the weighted gradient scale. Then there's the block threshold, the maximum objection index permitted before a blocking condition is triggered. The spec generalizes this at 0.30. And these two parameters are built into the predefined rule structure of the CDS, meaning the node has made this constitutional decision in advance. The parameters have been decided in advance. And one of the great advantages of having multiple nodes come online eventually is that these thresholds refine themselves based on experience, part of the collective consciousness of the entire network. If one node is having a strong success with a particular set of values, other nodes will see that and pick up on them. Putting it all together now, the consensus score. Here is how all of this comes together in the current state of the white paper. The calculation runs from the 4 inputs. The first step is producing a consensus score from the gradient votes combined with participant weights, if there are any. For our purposes, we'll assume everyone's weight is 1 or equal. Now you'll notice from an image I have on screen, in the current gradient scale, there is an asymmetry in how numerical values are assigned to positions of support. This is intentional. The gap between concern and block is larger than the gap between support and strong support. Hence, blocking carries disproportionate negative weight. This means that a small number of people blocking will drag the score down harder than an equivalent number of people strongly supporting will pull it up. It forces critical attention to be paid to the reasons someone wants to block or strongly disapprove of a proposal, rather than letting enthusiasm drown out principled resistance because everyone else generally agrees in the majority. And what you have is the following calculation for a consensus score, which is fairly basic. Multiply each person's preference number by their weight, add all of those up, then divide by the total of all the weights. And this gives you the overall direction and intensity of the group's preferences. A score of 1 means everybody strongly supports. A score of -1 means everybody blocks. A score of 0 means the group is perfectly split. And next is the objection index. Now, with the consensus score in hand, Module 6 now turns to the second half of the calculation. While the consensus score measures the overall direction and intensity of support, the objection index measures whether any principled objection is serious enough to warrant halting or revising a proposal, regardless of how much support it has. A key asymmetry of the system process. A proposal can be wildly popular and still be blocked if even one well-grounded objection crosses the severity and scope threshold. And again, this is what prevents the CDS from moving into a kind of numbers game where the enthusiastic majority overrides small groups raising a serious concern. The formula for the objection index is extremely simple. For each documented objection, multiply its severity by its scope, and then take the maximum value across all objections. And it's a critical qualifying concern because it's a safeguard against something really bad being decided upon without thoroughly vetting everything that is on the table. So again, the objection index is what ensures that the most serious concern gets evaluated. Now we are ready for the 3 possible outcomes of Module 6. So it now has these numbers, a consensus score, C, and an objection index, O. It compares them against the 2 thresholds from the rule structure, consensus threshold, the spec default is 72, and block threshold, the spec default is 0.3. From this comparison, one of 3 directives is produced per scenario. Outcome 1 is approve. If the consensus score meets or exceeds the consensus threshold and the objection index stays below the blocking threshold, the scenario is approved. In plain terms, enough people support it and no single objection is serious enough to block it. And if that's the case, all things being equal, a single scenario moves into Module 7 for recording as a decision and then into Module 8 for dispatch, where it becomes coordinated action across the other systems. Now, the second possible outcome is revise. If the consensus score falls below the threshold or the objection index crosses into the blocking line, over the blocking line, the scenario is returned to Module 5 for needed revision. Either way, Module 6 returns a directive to revise, along with required conditions that points to the meta information I just described, what needs to improve, in other words. The scenario goes back to Module 5 for further deliberation. And hence you may observe we have another cyclical aspect of the CDS. Revision is not failure, it's a normal part of the flow. If revision produces a genuinely new proposal rather than a mechanical modification, it should route back through Module 3 and 4 as tools, as stated before, returning to deliberation. And finally, we have outcome 3, escalate to Module 9. There are 2 conditions where things escalate to Module 9, and once again, it's a little bit murky in the white paper. First is when the cyclical revision process continues to fail, meaning you're constantly revising, but it's not improving in terms of consensus. It's just cycling between 5 and 6 and 5 and 6. In the white paper addendum section of the CDS, this is referenced with a persistent duration of disagreement across cycles as a variable. However, this is not expressed in the white paper in an expansive way, though it is in the code. And I think what you could simply do is come up with a number that says, well, if this happens so many times, an alert will say it might be time to go to Module 9's integrity. Now, the second trigger occurs in a far more subtle and subjective way, meaning even though it could probably overlap with the first as part of the objection that moves things to Module 9 and its integrity. But this is a case where it's not rejected. The consensus is sufficient, and there's no single blocking objection large enough to block it. But there is still a pronounced, outright stated, unresolved value conflict underneath the numbers that is apparent. I consider this an edge case once again, but as I started brainstorming this, it's like, what are all the possible things I can think of that can reduce the efficacy or do something wrong in this scenario in terms of the philosophy behind it? I had sketched all this out. You should see my notebooks on all of this stuff. And what it is, a more subtle trigger that has to do with values, referred to in the white paper as unresolved value conflict. Let's imagine we have a community and a very tiny percentage actually have a deep sentimental relationship to something like an artifact, a building, something historical that means something very specific to a particular group of people or individual. The ramifications of that value-oriented relationship has to be accounted for in civil society. It's a moral issue. If something is extremely severe, where you have to do something like tear down a sentimental physical structure because it's really necessary, that logic can play forward and will probably influence those that are emotionally tied to it. But as we see in the world today, like some huge corporation decides it wants to build something somewhere, and they're willing to buy out or rip down something of great historical value. We see this in Native American cultures. So much Native American land and resources and infrastructure has been disturbed by corporate industry just going in and doing whatever they want. I'm not big on sentimentality personally, at least not in the sense of physical things, but I can understand why others are. So that is the second trigger, and how that actually comes to be in terms of the trigger process would probably be far more casual than any kind of calculation. What could happen in the constitutional rules of the node is a thoughtful provision is put in that says, well, if the Module 6 outcome is achieved through all parameters normally approving, but there's still an objection that comes from this value orientation, some kind of appeal can be set forward, and that brings in a new sensitivity to it. This is an edge case, but I think it has to be accounted for. If you don't do these kinds of things, the ramifications can be technically disturbing. If someone in a node feels like they didn't have their values respected, again, as complicated as it all is, and they don't feel respected because of what happened, they might behave in adversarial ways. In the same way we see all across the world today, this sort of emotional disrespect that people showed towards each other, amplified like crazy, of course, in the current market economy. And what do you have? I remember reading about a guy just recently that burnt down his entire employer's building. And he said that comment, I'm sure some of you have seen it, that all they had to do was pay me a living wage was his statement. We generate so much toxicity by the fundamental myopic, competitive, and self-oriented disposition of so many people, and we are disregarding so many people in so many complex ways. And the repercussions of that, even though they're sparse, and I'm not saying they're appropriate, can be disturbance, violence, and terrorism effectively. And that edge case brings it into Module 9, where a different process, perhaps including integrity, is moved forward to try and come to terms with the conflict. So those are the two things that get escalated to Module 9. Now to wrap this up, assuming that moves forward, we end up in Module 7, which doesn't take much explanation. It's the documentation, stamping, metadata. It says, okay, this is on record, this is what we decided. What the actions are moves to Module 8, which dispatches the directives to get the decision going in the real world. Now, one more thing before I forget, because I'm trying to be as detailed as I can without being overwhelming, there are a few more clarifications for Module 6. Module 6 is likely going to have multiple scenarios to evaluate, right? And when it finishes running all of them for Module 5, it will produce a list of consensus result objects, one per scenario, each with its own consensus score, objection index, and directive. The orchestrator, meaning the coordinating layer that governs the flow between the modules, is what selects among them by comparison. If one or more scenarios returns approved, the strongest, highest consensus, lowest objection index moves forward to Module 7. It wins, so to speak, and hence to Module 8 for dispatch. If none are approved and one or more are flagged indeed to escalate to Module 9, the highest consensus escalation routes into Module 9 for the human deliberation. And if every scenario, say, returns as revised, the whole set goes back to Module 5 with the consensus results as the new information to consider in deliberation, and the cycle begins. So just to be clear, as it currently stands, and this is just a conceptual architecture on a certain level, even though I'm trying my best to make things technically coherent and have a sense of how this can actually work. Module 6 is running the calculations, but the orchestrator is what makes the comparative determination across all scenarios after Module 6 is done. I hope that makes sense. Just like the introduction of automated proposals between Modules 3 and 4, this step is done for the sake of consistency. So each of the properties are separated for the modules in terms of what they actually do. They don't have to be that way. You could combine different multi-step properties in each module, but again, this is for conceptual purposes only. And of course, it is entirely possible for multiple scenarios to come out of Module 6 and hit the approval condition at once, simultaneously. And when that happens, the orchestrator sorting step is what breaks the tie. The scenario with the best combination of high consensus and low objection index wins. So I'm about to keel over from all of this tedium. This is not a typical content array for a podcast. So we've already mentioned Module 7 and 8, so I think that's good enough for now. We could talk about the technical breakdown of dispatching the decision or the documentation and meta information of how a decision is stored, which of course is important because if it goes to Module 10 later on, meaning there's a review process, all of that data needs to be sound and reviewable. Now, one thing I want to just finally get to and reiterate in the spirit of all this, which I just alluded to, but I want to say it again. The structure put forward here is organized primarily by function. Each module represents a distinct cognitive role in the decision process. But the way those functions are combined and implemented doesn't have to look anything like the pseudocode sketches in the paper. Things have changed a great deal in the last couple of years. In fact, they're just changing daily, it seems, when it comes to data processing and this kind of move away from chains of narrow, purpose-built algorithms toward this more complex AI-driven model ecosystem, large language models once again. In many ways, LLMs are likely the secret sauce that makes something like the CDS far more feasible than it would be many years ago. We now have the ability to run locally hosted models without depending on cloud data centers that are, burning up the atmosphere and sucking up a bunch of water. And you localize these systems, you feed the constitutional constraints and policy documents directly into a novel model. You build the retrieval processes through these models, such as with Module 3, bridging other systems that have unique parallel systems of engaging or some kind of fluidity once again in the structure. And you can begin to see how this can take shape in a far less difficult way than what is proposed in the white paper, because it's more of a traditional type of approach. Moreover, the kind of evaluative processes can be far more subtle when you get to nuanced reasoning about things like values, subtle context elements, scope and severity, comparative trade-offs, which was really way out of reach, again, a long time ago. So while the logical basis and general reasoning behind the structure I've just explained holds up in my view, the way it actually gets implemented and expanded is likely to look quite different. Okay, folks, that does it for me today. I'll be back next time, which I promise will happen sooner than later, for the OAD, the Open Access Design System, which actually will be a lot more easy to talk about, much easier to talk about than this, as it's far less abstract than digital democracy. So we'll take it up then. This program is brought to you by my Patreon, and I will be sending out an email fairly soon to everyone that signed up for the Integral mailing list. I've got a lot of applications to go through. Really appreciate those that have done that again. And I will generally be in touch. And everyone take care out there. I'll talk to you soon.